Dr. Chuck the Science Schmuck. Synchrona. Now you can't see it because you've seen me and the pink wall, but there's a lot of junk in this place. Junk that I had to pack in boxes in a very wet, smelly basement. Something just became silent, and it wasn't me. I had to pack it into a box, put it in a truck, put it in another place, wait like 2 months. That's how long it took me to move. It was about 3 to 4 months. And then carry it all back. So I've been going through the various debris that I've accumulated, and my goal ultimately with this video series is to use up most of it because I have to move again soon, and I don't want to have to pack all of this. And a lot of this stuff can hurt me pretty severely, and that's what you came here for. Unfortunately, this experiment probably won't. It'll just make me sad. Although it is based on technology that did work, because while I was digging through various detritus, found this. That's a heap of electronics, partially made out of milk crates and weird random wood that I probably found in my parents' garage at some point. And you may say to yourself, well, what is this? This is the remains of a multivibrator. It's a specific type of circuit. Specifically, this was probably one of the first working instruments I made close to 10 years ago. I've scavenged a lot of pieces from it over the time because I stopped using it when I stopped producing music, which was something I did when I was much younger. Now, part of that is I don't know entirely what's here, so I'm going to go through an examination of what this actually is, reverse engineer what in the world I was thinking, and then try to get it running again with new and improved components so that it can serve in my various menagerie of poorly conceived musical instruments. Okay, so what am I actually looking at? Okay, so these two strips of material appear to be a large number of switches, which I believe are in parallel. There's push-button switches, which I think were designed to act like instrument keys, but also a lot of these very tiny slide switches. I'm assuming that the intent of that was so that I could play these like a musical instrument, click them to make a specific sound, but I could also turn on a switch to sustain that sound so that I didn't have to hold down multiple keys, which musically is kind of interesting in that it doesn't really answer to me why I would have thought that was a good idea. But I actually did a good job color coding them. I think these wires are meant to be the cathode. So there's two sets here. What is that? I'm getting ahead of myself. There's two sets here. This set looks like it's connected to... So one wire comes in, one wire comes out. This wire isn't connected to anything at all. So that's a bit of a mystery wire. This is a piece of white milk jug. When was the last time I drank white milk? All my milk is brown. Because it comes from brown cows. How now, brown cow? And weirdly, it leaves like calcifications on the inside of the glass. Because I drink from the same glass a lot, because soap is expensive. Other than soap, this appears to be a bunch of random capacitors jammed through this and connected to these, which I actually drew a schematic of the type of multivibrator. It's the standard 555, or as people call me, the 555. Not to be confused with the 666, which is the tiny integrated circuit that summons Satin. The 555, when connected in this way, produces a... I just tapped your ears. Sorry about that. I'm not sorry in the slightest. But the 555, from my understanding, it's very literally black box to me. But in the multivibrator, rather than monostable vibrator... Okay, so it's actually a monostable versus astable multivibrator. This formation for this schematic is the astable multivibrator, which produces a continuous function, whereas a monostable, when active, will produce one peak that then drops off. Useful for like robots and stuff. This is useful for making sound. It has from my understanding, these two pieces represent this capacitor and probably this resistor. I think there's another resistor here somewhere that's just built into the system somehow. The idea being that by changing that capacitor and changing the resistor, you can change the frequency, which produces different musical effects. So if I chose a capacitor that was high capacitance, it would produce a low frequency. If I chose one that has low capacitance, it would produce a high frequency, because from my understanding, the actual circuit mechanism of this sort of capacitor-based oscillator is based on the idea that a capacitor is filling and emptying, and filling and emptying, filling and emptying, filling and emptying, filling and emptying, filling and emptying. And that's what produces the frequency. So you control the frequency based on the size of the capacitor. A big capacitor takes a long time to fill up and empty, making a big wave. A little capacitor fills up and empties quickly, producing a high-pitched wave. The resistor controls the feed by which that capacitor is fed, which controls its rate also. The resistors are these blue-green wires, which are a little rusty, and a lot are broken and disconnected from everything. It's set up the same way, but it also has these, which are potentiometers, which a potentiometer is a variable. Somebody's slapping the wall behind me, but they can't get through unless they got an axe. I hope they don't have an axe. A potentiometer is effectively, well, it is a variable resistor. You say, why are there variable resistors here? Because it allows you to control the sound in such a way that it ramps up to produce an interesting effect. And you say, well, why don't you do that with the capacitors also? I say, have you ever tried to find a variable capacitor? They're really weird devices that are not commonly seen on the surplus market, which is where I got all this junk from. Variable capacitors are expensive and usually big, at least in my experience. They're designed for radios, and the actual variance in capacitance you get is very small, so it's not really effective for that type of... I think when I was using this, what I ultimately discovered is... So now for the real Archaeotech stuff. Oh, there's the resistors. I don't think some of them are resistors. I think... I don't know what that is. That's not a normal resistor. I buy surplus stuff. I have something in my eye. As long as it's not a resistor, it shouldn't be a problem. This is the brain, which... This is the hard part. So, with the brain, that's actually the circuit. This stuff's all straightforward. I understand what it is. It's a common connection going to capacitors and switches, and it looks like a mess, because it is a mess. But it's pretty straightforward. It's just capacitors and switches all in parallel. This should match up with this. Aside from the mysterious extra capacitor, I don't think I've ever included that capacitor. I don't know what it does, but it doesn't look like it's built in here. So, this is the confusing part. First of all, there's two tiny Radio Shack breadboards there. It looks like they're offset with maybe pieces of drinking straws. What is this? Because I do not think the output of this has a transistor. 78M05CTQVK930. That strikes me as a voltage regulator. Considering that this is a 9-volt connector, and it connects directly to this little TIP-looking thing, I don't think that's an output control transistor, which is weird, because most of the modern systems I've built for this in the past 2 or 3 years have all been driving motors or big stuff, and the 555 can handle a lot, but it can't drive a large motor directly, so it usually has a big output transistor. That's how I construct it now. But this has a voltage regulator going in, which is weird because the 555 handles up to 18 volts. I guess when I was making this, I assumed that it needed 5 volts, which is probably what that is. I can look it up later, but I think that's a voltage regulator because it does connect back into the circuit, and it does have these 2 green wires that are sticking out and not connected to anything at all. Which, if that is a voltage regulator, and it's meant to regulate incoming voltage, these are probably what was originally connected to a power jack, which would make sense why I put that in there originally. I think I have some of those things. So this has a 12-volt output, which is within what the 555 can handle, especially if there's a voltage regulator. It plugs in to the wall and it gives you power. So that this thing was probably one of the first circuits I built that could be plugged in, because back then I was actually afraid of the electricity that can kill me. Now, since I've realized the sum total of my inherent immortality, I'm not really afraid of anything anymore, which is kind of a sort of cold, immortal existence. This was probably built before this technology existed, and that you'll notice this is very light. Everyone in the world is younger than me at this point because I'm like 43, and this technology probably didn't exist when this was made. Power adapters that plug into the wall and make electricity with these little cool solid state pieces, like what your phone charges off of, weren't really a thing yet. Cell phones weren't quite a thing yet. Most of what you would use to power something like this was the big, fat, old, heavy wall warts. Yeah, this is one of them. It's a wall wart. Made in the Danyang No. 2 radio factory. Output 12 volts at 500 milliamps. Whereas this is an output of 12 volts at 1 amp. So this is actually substantially bigger than this, and probably was much cheaper. You can't tell because you don't have hands in my world. Well, you probably do have hands, but they're your hands, and you're watching this in the future, so what your hands are doing now, at this time as I'm filming, I don't want to know. But this is very light. It's just a tiny circuit board inside a plastic housing. This is very heavy. That's because this technology, and the reason I call it wall warts, these used to be everywhere. You would plug them into the wall, and they'd power your various small electronics that didn't otherwise have internal power supplies. And they just lump up and go everywhere. This actually has a transformer in it. So there's actually wires wrapped around coils and stuff instead of just solid-state circuitry. Which, back in the ye olde days of yore, these things used to be plugged in everywhere, and they continually draw power even if the thing's not connected, supposedly. So you could actually get a substantial power bill just with like 50 of these in your house. I think I probably built this voltage regulator with the intent of using one of these because a weird feature, supposedly, about some of these is that the actual output voltage is not constant unless the resistance is. I don't know why that is. You're talking transformers, and you're talking impedance. It is literally the only thing in the world I know that uses the square root of -1 as an actual number in its calculations. So don't ask me why that is. But I think I had the fear that since the resistance of this circuit was not really meant for one of these, it would just overload on voltage. This thing was made in 2004? I am very old. So this voltage regulator isn't strictly necessary now, but I'll probably still use it because it's here. These will get reconnected to an adapter for this so I can plug it in. So I've figured out what that is. So we're making progress. Now, in terms of the rest of the investigation of the actual 555 itself, now, if I was smart, and this was before Radio Shack closed down, and instead of circuit boards, I started using just milk jugs and basically freeforming everything into giant masses of electronics that almost once blinded me from exploding. So with the 555, one should be connected straight to ground. So wherever one's connecting, one is the top corner near the notch. So yeah, that connects to negative. And then other negative is called the positive. That connects to pins 4 or 8. Okay, so positive is on this side, and negative is on that side. So that makes a question of what these stripy wires are. Why are these stripy wires connected to pins 3 and positive? Okay. Well, pin 3 is the output, which is what the frequency comes out of, and positive is positive. So, interesting fact about the 555, and people have argued with me about this because they say, no, it doesn't do that, but the actual output is not, mainly a conversation I have with Jungle Jim, in that the technical definitions of DC, when it is not flat DC, it's no longer DC, even if it is DC, because DC that is moving in a square wave is actually offset AC, technically. And I say it's pulsing DC. It's going in one direction. He's like, no, it's offset AC. This doesn't produce an AC output. It can if you link it to a transformer. That's a weird trick that also people tend to forget is a thing. The number 3 actually outputs as positive. It's a digital signal, so it's positive, then full negative, positive, negative, which doesn't actually mean anything except unless you actually connect that to PNP and NPN transistors, and then when it's positive, you can trigger one transistor, and then when it's negative, you can trigger the other and have two alternating things. That's how you make a little railroad light effect if you have two LEDs. In this case, it is only going to positive, even though it could go to negative. So that's the output. These stripy wires are output. Not that, that's a permanent marker. I've lost so much hair that I can now buy Sharpies at the store without, like, 4 Walmart associates coming up and, yelling at me, because I now look old enough to be able to buy my own Sharpies. Back in the day, you couldn't buy those because back when I was young, kids sniffed glue and Sharpies because they were dumb. Although, they say sniffing glue kills brain cells, and it most certainly does, but if you were dumb enough to start sniffing glue, you probably already didn't have very many brain cells. I hope the glue sniffers don't get offended, but you should stop sniffing glue. Eating glue? That's probably fine. It's not especially toxic, unless it is, but sniffing it is bad. So consider that my public service announcement. Don't sniff the glue. You'll end up like I did. What was I talking about? A really rusty paperclip? I don't know what's going on anymore. But I do now know the basic layout of how this circuit corresponds to this diagram. It is now a matter of reconstructing it. And I actually need an additional few parts. So let's see, the first thing I need to do then is figure out how I'm going to mount this back up in a way that actually makes logical sense. And literally rebuild the thing so that it's physically reconstituted on the capacitor and resistance side. So I probably will need to cut those off. And then I will need to rebuild the circuitry here and have the necessary output-input system. Okay, that's what I'll be doing next. And then I'm gonna... Oh boy. Okay, oh, my voice. Where's my voice gone? Oh no. Well, aside from my voice having mostly disappeared, it appears that I have somehow managed to complete stage 1. That stays over there. So I cut off the brain, which is all this parts, because that will get reassembled elsewhere. And then I found this piece of wood, which actually was originally from my attempt to build another device that never actually made it to video because I couldn't get enough current to actually cause damage to things. That's the one that exploded and nearly blinded me. So I took everything off the piece of wood, and I glued these to it. Although not with glue, they are actually... The original version of this seemed to be held together primarily with hot glue, which I guess was structurally fine, but not really for long-term use. So I used nails. Nails. Because screws are very expensive. I didn't want to undo those assemblies entirely because they're really... lots of holes, lots of soldering must have gone into that. So I cut them off, labeled everything with this blue tape so I can figure out how to reconnect it. But I don't know what this is for, or why those are there. I think I'll figure it out eventually. All these little switches had come up. I re-glued them. They didn't have glue under them, so I put glue under them, put glue on the sides, and then I used these metal bars to glue the back sides down. So those are really well on there. Those aren't really designed to take a huge amount of tension. They actually weren't very much used, if I recall. The buttons can be pushed, so the idea is that this, when complete, can be operated from this end, almost like a piano, except you would actually not ever use both of these resistance and capacitance at the same time. The actual resistors and capacitors have been folded in under the bottom, so the circuitry and brain will probably end up on the bottom, and interface aspects will be on the top, and then I'll put frames so that it'll be like a little cabinet. It'll look super hillbilly, but that's probably fine, because ultimately all that matters is that it works. The next stage then is figuring out this part, which is reconnecting both the brain And interestingly, these potentiometers are all in series, which I did not expect. So it'll be reconnecting these here plus the power node, or not nodes, but the power connectors and the output jacks, which probably will require a little bit more complicated woodworking to make those stable, because that seems to be, those are the parts that have broken off the thing. So I think those were poorly conceived in the first round. So back to it, I guess. I've assembled some additional components, namely I have grafted the circuit's brain into the bottom of it. I have also applied this plug, which I stole from another thing, so I'm going to have to buy more of those. It was real rusty, copper rust, so copper carbonate everywhere, but that's connected to an audio cable. This is the power supply, which I have wired to this light switch that I'll eventually glue there, but otherwise, it's time to give it a test. Now, that's why that's connected. You can see that the jack itself is not holding anything. It's stuck through a piece of aluminum that I drilled a hole in. That's actually holding that. So that's a standard 3.5 audio cable. It fits neatly right in there. Power supply is behind me. Now, in order to test it, this device doesn't have an internal speaker. I don't think the original... What does this go to? Whatever those go to, I don't care right now. They weren't labeled? I don't care. I'll add that later. I don't think this device had an internal speaker to begin with. It's designed to take an amp, which I have this small guitar amp. So I'm going to point that at me. Interestingly, because you're actually receiving sound from here, it's closer to... It would make logical sense for the speaker to face you, because that's where you're standing or sitting, and that's where you would hear it, but in actuality you're hearing sound from right here. So I'm going to plug this in. I'm going to flip the on switch from off to on. I'm going to make sure the volume is all the way down on this, and then turn it on. Then I'm going to turn up the volume. Now right now nothing is set in theory. Okay, so when absolutely nothing is connected, the circuit's just sort of floating and you get this 60 hertz hum, which is just the lights basically. So if I click on a capacitor, it fills enough of the circuit that doesn't happen. But I can use that to adjust the volume. And then let me select one of the capacitors in the middle. Now, by pressing the resistor buttons, I should produce a tone. Okay, that's a very low frequency, characteristic of a low square wave. Higher square wave. Ooh. Let me turn that down. Hopefully no one's sleeping. Well, that's part of the problem, I think, is that the switches are not actually very good. So it's oxidized and not getting a great connection in there. Oop. Now, in theory, I can select a constant tone by selecting one specific switch, and then I can cut that. I can choose also to set a resistor, let's say this one, and then choose different capacitors. That's the only one that makes noise and it doesn't do it so great. It works better, I think, if I select a capacitor. It's a very low frequency. In fact, why don't I just hand it over to you? connect to anything, I guess. It's not an ideal circumstance. And that's the part where I'd normally give up. That drill's looking at me and I don't trust it. But this time I'm not giving up because I've built the circuit to the degree that it functions. And I get the impression that when I originally built this, it was designed to be a more keyboard-like device. But I don't think I used it like a keyboard. So I've got two obvious problems. One, fermenting gelatin smells really, really, really bad. And it's over there from the Winogradsky project, which is occurring simultaneously as what I'm doing right now. So it smells really awful. The whole place smells like a diaper exploded. Two, there's a squirrel trying to gnaw through my wall and get in. This is why I don't like to do this in the middle of the day, because all this stuff is weird. I can't smell at night. There's no squirrels at night. Hold on, legit, I have to go, like, kick the squirrel off my house. And now let's see. The output of this system, as before, consists of this cord, which is linked to this amp. So let me turn on that amp. I don't know why it's doing that exactly, but I'm fine. All switches are in the off position, including that one. Okay. The hissing buzzing sound is gone. Two of the main things that I had to do to correct the problems with this thing is, one, I had to resize some of the capacitors. The big ones didn't do anything. They made frequencies so small you can't actually effectively hear it. And I couldn't get high enough to actually be able to get high end. Two, however the potentiometers were supposed to be hooked in did not work in the slightest, so I gave them their own independent little switch that I glued to a block of wood in the center of the thing to turn on and off the potentiometer. Three, this switch is now always meant to be on. That switch is of particular interest because I have connected it to these two metal plates. You say, well, why have you connected it to metal plates? Because essentially these metal plates are acting in the place of a resistor. What does that mean? It means that I can be the resistor if I'm willing to pass the electricity of the circuit through my body, which I am. So first I'll connect a capacitor and I'll try it with the switches to see what it does. Doesn't do diddly squat. The reason it doesn't do diddly squat at the moment is due to a very technical problem and an error that I did not think of when making this. That problem being that when a light switch says the word off on it, the switch is off. Rather than, for some reason, this is not the first time I've made a stupid like this in the last 2 days. For some reason I was thinking that when the light switch points away from off, it means that it is on. That's the free-floating tone. Okay, so let me put in a capacitor. That is one of the ones I added. It was a 103. It's green for some reason. I don't know why. I found it in my box of random capacitors. So that connects it into the circuit, gets rid of that, noisy tone. So selecting one of these, that's kind of the ultrasonic, getting to the ultrasonic frequencies. Those don't do anything because at that point the resistance doesn't effectively matter. The reason I needed high-end capacitors, or high frequency capacitors, which is a low capacitance capacitor, is because if you're using the human body as a resistor, the human body has a pretty high resistance. It's a couple mega ohms, so very tiny capacitor, very big resistance still produces an audible frequency. So if I place one hand on here, So in this case, the actual output frequency is dependent on my effective resistance between the two plates. That depends both on how much surface area I'm using, so if I touch it with just one finger, you get a low frequency. If I touch it with 4 fingers, I get a higher. All fingers, and it goes up real high. Pressure also has a difference because it determines not only surface area, but also the connections and how much of your finger is actually connecting to the metal plate. So that's just one finger on each side. So changing the pressure can change the frequency directly. That can also be set theoretically to other capacitors. Like that one is much too low. Even pressing all the way down, I can barely get anything. That one's more of a bass frequency. What's this one do? Still too low. That's another high one. I'll go back to the first one. Now, in addition to that, I found out that whatever system is supposed to connect to the potentiometers doesn't actually work, like I said before. So I glued this little switch in here. The interesting thing about the potentiometer switch is that potentiometers are effectively constant. They're effectively variable, but since they don't... This only works when I'm touching it. The potentiometers are always there. So this is a potential use of these capacitor switches. So when I select that capacitor by holding down the button, it sends it through the potentiometers instead of one of these internal resistors, which means that when I turn them, that's a very slight change, right? That's because there's two of these. One's high resistance and one's low resistance in series. I need to get a knob on that one. It's very slippery, especially because these are greased for oxidation purposes. Now, one feature, I'll turn down the volume a little because this can get a little annoying, is that that just passed my range of hearing. That switch is not ideal. I don't know where I got it, but it sure is hard to flip. Might need to grease it. Bad idea to grease a switch. Interestingly, I found that with these potentiometers, the low-range potentiometer only really has an effect when the high-range potentiometer is turned to its minimal resistance. I think because they have an exponential effect. So a big, huge resistance on the first one, and you're only changing a little bit, and it doesn't really affect it. But when you have a little resistance, and you're making changes within that, it actually affects it exponential to that. I am sure there's math to it, but I only know it basically empirically. So the potentiometers do work now. I tried adding the whole bunch of them, but essentially you don't need that many, because one potentiometer can do the same thing. It's just the resolution you get for turning the knob differs. I did try hooking one in as volume control. The thing is that doesn't really work because this is an amplifier. An amplifier is designed to pick up the tiny electromagnetic signal, a tiny electrical signal of a guitar being plucked. This is just putting out like 5 volts. So no matter how much resistance I put on it, you can't put a big enough resistor to make this not really work, other than just changing the actual volume on the thing. So I had to turn the gain down, basically, on this thing. What is that? I don't know what that is. There's a switch on this. I think it might be distortion? As fun as it is for me to mess with it, it's probably not very interesting to whoever's watching this. The point is that I have converted that old piece of technology that had broken apart and no longer been useful for me into one that is still almost as broken, but functionally viable for full operation. It's now much sturdier. It's held together with screws and hot glue instead of hot glue alone. Let me disconnect these plates so that I can pick the thing up. Weirdly, this plate has an alligator clip. This other plate is held on by an alligator clip. And that's an entirely different issue. And you can see the top view of the machine in question contains all the interface. The bottom contains all the circuits. It's pretty sturdy. You can sort of set it down wherever you want. So that's a musical instrument right there. To what end this music could actually be used for, I probably knew once, but I'm going to have to figure that out on my own again, because I do not know how you would actually play a musical note on a device like this. It produces weird combinations of frequencies. And it's kind of grating. And just like that squirrel. But that's actually one of the only effective projects I've ever done. It actually made something work, and all I had to do was use something that already worked before I made it not work. I gotta go get rid of a squirrel, I think. End.